All right, what's up guys? Welcome back. So in this video, we're gonna go over some differentiation using logs. Now it's super important that you know your log laws, as you can see on my screen. So you've got the product, the quotient, the power, and change of base. They're really the fundamental ones that you need to know. There are a couple that come in handy, but these four are the main ones that you need to know. All right, before we jump into the examples, the formula is this. So d over dx of ln g of x is equals to, so the derivative of this function, when you have log of some other function, is 1 over g of x times by g dash of x. Okay, so in all, that's going to be g dash of x over g of x. So basically the derivative of g of x on the top and then g of x on the bottom. All right, let's look at this example here. So y is equal to ln 2x. Now we just learned that we need this g dash of x over g of x. So y dash here, well, what's the derivative of 2x? Well, that's just 2. And now you put the original function on the bottom, which is 2x, and you're done. I lied, you gotta simplify. So y dash is equal to 1 on x. All right, let's do this example here. So differentiate y is equal to ln 3x squared plus 1. So once again, we need the derivative at the top because it's a log. So y dash is gonna be the derivative of 3x squared plus 1, which will be 6x over the original function. So 3x squared plus 1. Done. All right, let's look at this example here. So we've got y is equal to ln 2x minus 1 over 3x plus 4. So we've got a fraction here. Now, we're not going to be doing any quotient rules because I know that I can split this log up using my log laws by writing it like so. ln 2x minus 1, take away ln 3x plus 4. Now what I can do is I can differentiate this first, and then I can differentiate this second. So here we go. Y dash will be the derivative of 2x minus 1 is 2 over the original function minus the derivative of 3x plus 4 is 3 over the original function. So that is my first derivative there. Now you obviously could bring it all together and make it one fraction, but for this video, let's just leave it like that. Okay, so 5. Differentiate y is equal to ln x all to the power of 5. Okay, now this one is interesting because this is not the same as ln x to the power of 5 like that. Okay, these are not the same. I'll go through this example in a second, but let's look at this one. So what I need to do is, because the power is on the outside, I need to bring it to the front, make that 5 ln x to the power of 4. And then this is chain rule. So now I need to differentiate by what's inside. So ln x is just 1 on x. So my final answer should be 5 ln x to the power of 4 over x. All right, so the reason this question is interesting is because these two look super alike, but there's a big difference here. Okay, so really take that into consideration. If this question on the right-hand side was y is equal to ln x to the power of 5, like so, what I can do is I can use my log laws, the power law, to bring this 5 out the front, and that would make that y is equal to 5 ln x. And now I can just differentiate with the 5 out the front as a constant. So all I need to do is times by the derivative ln x, which is 1 on x. So y dash is 5 on x. Done. All right, that's it for this video. In the next coming videos, we'll do some ones where we involve other functions like trig functions or exponentials. But that's it for today. If you have any questions, let me know down below. Otherwise, I'll see you in the next one. Peace.